All that waiting has paid off. Here it is, the first ever image of a black hole. This incredible photograph is the result of a planet-wide effort by radio astronomers and their telescopes, petabytes of data, and an incomprehensible amount of computing power. The supermassive black hole at the center of the distant galaxy Messier 87, an object as big as the solar system, which absorbs all the light and matter that falls into it. An object with 6 billion times the mass of the sun, and you're looking at a photograph of it. Today's a very good day for astronomy. If I go back through the comments here on YouTube, I can probably find dozens of questions asking me when we're going to see the first photograph from the Event Horizon Telescope. And I kept saying spring 2019. Well, we're only a couple of weeks into the season, and already astronomers have made good on their promise of showing us their first image. But you might be surprised to see that it's an image of the supermassive black hole at M87, and not the one at the center of the Milky Way. That's true, and it's still coming, so I'm going to have to ask you once again to be patient. Astronomers from around the world made a huge joint press conference that was live streamed onto the internet on Wednesday, April 10th, 2019. They shared the results of 200 astronomers collected into 6 separate papers. And they shared this picture. The photograph was taken by the Event Horizon Telescope, which isn't actually a single telescope, but a worldwide network of radio telescopes. There's one in Greenland, several in North and Central America, a few in Europe, one in South America, Hawaii, and last but not least, a facility at the South Pole. For 1 week, in April 2017, this entire network of telescopes pointed their collective antennae at the supermassive black hole at the heart of the galaxy M87 and recorded petabytes of data. They recorded radio waves at the wavelength of 1.3 millimeters, precisely synchronizing their observations using atomic clocks. By all recording at the same time, the separate telescopes were able to act like a single telescope the size of planet Earth. Although M87's black hole is enormous by black hole standards, containing 6 billion times the mass of the sun and stretching across a volume larger than the solar system, it's relatively tiny in the sky because it's so far away, about 54 million light years away. Just for comparison, the hilariously less massive but still super 4.1 million solar massive black hole in the Milky Way is only 26,000 light years away. M87 is 2,700 times farther away. Part of the challenge was the fact that the South Pole telescope is, well, at the South Pole, which is inaccessible for much of the year. Scientists had to wait until the southern hemisphere's summer to actually fly out the hard drives after the observing session. All of the data was stored on hard drives and then transported physically to centralized locations where they could be crunched on supercomputers. 4 separate teams worked on the data completely independently, so they couldn't influence each other's results. Peer review has a parallel process. Then, in April 2018, the teams brought their separate photos together and saw that yes, indeed, they did get the same result. Finally, 5 petabytes of data stored on half a ton of hard drives was shipped to Harvard, where the final data was integrated together, and this is the result. The Event Horizon Telescope had 4 main science goals. The first was to just take a picture of a black hole, to see the disk of glowing gas and dust surrounding the event horizon, the region where the gravitational pull is so strong that nothing, not even light itself, can escape. To perceive the ring-like structures with the dark central region, to match the actual image with the theoretical calculations that astronomers have been predicting for decades. According to Avery Broderick, a researcher at the University of Waterloo, it turns out our predictions were stunningly close. We were spot on. The second goal was to test, once again, that Einstein was right about his predictions for general relativity. Einstein, correct again. Goal number 3 was to understand the accretion disk that surrounds a black hole. That's where this image really shines. You're seeing the vast swirling disk of hot plasma surrounding the black hole, traveling at nearly the speed of light as it whips around the event horizon. One side of the image is bright because the gas is coming towards us. The other side is dark because it's moving away. Finally, the team wanted to study the vast jets that blast out of M87 and many other black holes. These are thought to be created by the differential speeds of rotation between regions of the accretion disk. These generate powerful magnetic fields that coil up above and below the black hole and channel hot plasma out into space at nearly the speed of light. We see these jets as quasars, the brightest objects in the universe when they're pointed right at us. When I saw this photo and learned that it was M87, my first question was, when do we see Sagittarius A star, aka the Milky Way's supermassive black hole? I talked to Dr. Ian O'Neill, who worked on the story for the University of Waterloo, interviewing Avery Broderick as one of the researchers on the project. It turns out the Event Horizon Telescope has a harder time with dust scattering from the Milky Way, obscuring our view to the heart of the galaxy. It was a relatively clear view to M87, so the team decided to release that image first. But I've also heard that they started with M87 because it's more than 1,000 times more massive than Sagittarius A star. Plasma is whipping around our local black hole, potentially brightening and dimming the image in a matter of minutes. Things unfold more slowly out at M87, so it makes sense to start there first. The stunning success with M87 means that the Event Horizon Telescope could turn its collective gaze on other targets, using even more telescopes that get added to the network. In fact, these telescopes will come together on a regular basis, gathering even more data on M87, Sagittarius A star, and other supermassive black holes near and far. Which means that we still need to wait for the Milky Way's black hole picture. Right now, I don't even have a tentative date for when we'll see that photo. I promise you, as soon as I know, I'll tell you. I promise. But like I said, it's a great day for astronomy. What an amazing accomplishment. What do you think? Let me know your thoughts in the comments. Once a week, I gather up all my space news into a single email newsletter and send it out. It's got pictures, brief highlights about the story, and links so that you can find out more. Go to universetoday.com/newsletter to sign up. And did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes show up right on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts, and I'll put a link in the show notes. And finally, here's a playlist.